Hello everybody, I am Vakar Mangi from Light Academy Secondary School. I am a maths teacher. I am here to discuss about the decimals for S1 class. Today we will be discussing about the definitions and some activities about the decimals. So let's go. Yes, decimals. Firstly, we need to understand what are the decimals. We need to go for the definition. A decimal is a fraction. You know, a decimal is a fraction whose denominator can be expressed as a power of 10. So any fraction whose denominator is expressed in a power of 10, that number will be a decimal. So by getting it very well, we can go for the example and we can understand from there. So we have an example here. Here is the number 45 and 6/10 written as 45.6. So you can check it here. That point is called a decimal point. This point is called decimal point, and 45.6. You can check it out. 4 tenths are there, and 5 ones are there, and 0.6 are there. But here we need to be very careful. 10 tenths and tenths. These two things are very different. Okay, they are not same. Okay, tenths is different. Tenth is different. Tenths is coming after the decimal point. Okay, and tenths, it is like you can say it. Okay, 10 10 10. 4 tenths means 4 4 4. 10 10 10 4 times. Okay, so we can say it like that. The decimal point goes between ones, every time between ones and tenths. So whenever you see the decimal point, you will be observing that the decimal point will be between ones and tenths. Okay, yes, 45.6 has 4 tenths, 5 ones as I have said, and 6 tenths. So it can be written like that. For 45.6 is equal to like 4 tenths. You can check it out how many rows we have. 1 2 3 4 rows. Okay, and how many like we can say it is a tennis ball. Okay, how many balls we have? 10. And you can check it out how many rows there are. 4. So it means there are 40 tennis balls, and 4 tenths, 5 ones, and 6 tenths. So we can understand from here that 45.6, how it will be written in the decimal point: 4 tenths, 5 ones, and 6 tenths. Okay, so let's go for the another example. Okay, you can understand. Yes, so we have a bigger number here. We can understand very well. We have the number 327.4. so here we can understand it 327.4. so you can understand from here that we have 300s, 220s, sorry, 2 tens, and 7 ones. Okay, point, this is the decimal point, and 4 tens are there. So you can understand from here 327 and 4 tenths. Okay, but like if you check it out after decimal point, if there's just one number, it will be a tens. Okay, but if we have more than one number, so it will be in the power of 10 number. Okay, but we usually just say 327.4. this decimal point, say it point 327.4. it will be written like that, and we will be reading it like that. Okay, yes, we have subtopic 3.5, convert fractions to decimal and vice versa. So here we are going to convert the fractions into the decimal. Okay, so whatever the fraction will be there, we will be converting into and decimals. Okay, so you can check it out. The first question is 21 over 40. 21 is divided by 40. But as you just notify that 21 is a numerator and 40 is a denominator. So whenever you divide any number in the fraction, the numerator needs to be a bigger number. Okay, to be divided by the denominator. But here you see the numerator is a smaller number and denominator is a bigger number. So we can go for the solution. We can understand from there. So check it out. 21 is divided by 40. Okay, but 21 cannot be divided by 40 because 21 is a smaller number, smaller than 40. So what we do, we put one decimal point here and we give 10 here. Okay, when we put 0 here, the worth of that number increases. Okay, it will be from 21 to 210. Okay, so it will be 210. So 210 can be divided easily by 40. So 40 by 5, when you multiply 40 by 5, that gives you 200. When you subtract it, it gives you 10. So again you can check it out. 10 cannot be divided by 40. So again we are putting 10 there, and it makes the worth of that number 100. So 40 divided by 100, we can multiply 40 by just 2 times, not 3 times, but it increases from the 100. So 40 by 2, it gives you 80. When you subtract it, it will be 20. So you check it out. 20 is also smaller than 40. So again we put 10 there, that increase the worth of that number, it makes 200. So now 40 exactly can be 200 can exactly divided by 40. 40 by 5, that gives you 200. So when you subtract it, the remainder will be 0. Okay, so when the remainder is 0, one more thing I will inform here. When the remainder is 0, so you check it out, that number will be a terminating decimals. Okay, if the remainder is 0, that number will be a terminating decimals. So here you can check it out. The question is 0.525 and the divisor is 40 and dividend is 21. The answer will be 0.525. 21 upon 40 is equal to 0.525 in decimal points. Hope you got it. Yes, question number 2 is 1 over 3. 1 is divided by 3. So again you can check it out. Before we go for the solution, you can check it out. The numerator is smaller and the denominator is bigger. So what we do here, when we are putting 1 here and when we are dividing by 3, we cannot divide. That's why we put one decimal point here, and by putting 0 here, it increases the worth of that number and makes it 10. So 10 can easily be divided by 3. 3 times 3 is 9. When you subtract it, 1 comes here. Okay, 1 remains. Okay, so again, like 1 is not divided by 3, so that's why we put one more 0 to increase the worth. Okay, so again 3 times 3 is 9. When you subtract it, it gives you 1. So it goes like that. Okay, it is going like infinity, like you cannot get the last number as a 0, so it goes like that. Okay, 0.33333, it will go like that. So that's why when the last number is not 0, so that decimal number we say it non-terminating. Okay, because there is no any limit of that numbers after the decimal point, and we say it in other words, we also say it repeating decimals. Why we say it repeating decimals? Because after the decimal point you can check the numbers, it is just same number. Okay, repeating again and again, again and again, again and again. That's why we say it repeating decimals. Yes, question number 3. 17 divided by 45. We need to change this fraction into the decimal. So 17 is a numerator and 45 is a denominator. So what we do, we divide 17 by 45. So 17 we replace here, and when we are dividing by 45, we cannot divide because 17, the dividend is a smaller than divisor. So what we do, we put one decimal point here and we replace 10 here. When we put the 0, it increases the worth of that number, it makes 170. Okay, now that number can be divided by the divisor 45. So 45 by 3, that gives you 135. When you subtract it, it leaves you 35 back. Okay, so again, like you see, 45, the divisor is bigger than dividend. Okay, so we put 0 there, so it makes 350. So again you divide by 45 by 7, it gives you 315. When you when you subtract it, it gives you 35. Okay, again you are putting 0, then again you are multiplying by 7, it gives you 315, and when you're subtracting you are getting 35. So same it will go like that. Okay, 0.377777, it goes infinite, means you cannot count the numbers. Okay, so why? Because you are not getting the last number as a 0. That's why it will be going same 0.377777 like that. Okay, so we have some explanation here, we can go for that. For 17 upon 45, when 17 is divided by 45, the quotient is 0.7777. you can see some dots are there, it means it is going. Okay, it is not stopped. So, and the digit 7 is repeating again and again, so we can say it. Therefore 17 upon 45 is a recurring decimal. So what is the recurring decimal? Actually, recurring decimal means, like, after the decimal point, if the same number is repeating again and again, that number is your recurring decimal, means it can be recurred. Okay, in fraction. Yes, we have a different topic here, changing decimals to fraction. Firstly we were doing from fraction to decimal, and now we are going to do from decimal to fraction. So here we have some example. To convert alternating decimals, the denominator depends on their position from the decimal point. If it is a terminating decimal, means like if it is after the decimal points, the number which are there, we can calculate that are the terminating decimals that can be converted into the fraction. So we have 0.08, it can be converted into the fraction. How? After the decimal point you are going to count how many numbers are there. 2. So it means we will be putting 2 zeros in the denominator, that will give you the fraction of the decimal point. So 8 is same there, and downside you can check out. Because of that, after the decimal point we have two numbers, we replace by 2 zeros, so it will be 8 upon 100. And when we simplify it, it gives you 2 upon 25. We simplify it by 4, I think, and this 100 by 4, that gives you 2 upon 25. Hope you got it. The other example is convert 0.27 bar. This actually line is called bar. This line is called bar. Okay, I'm going to explain it why we are putting this slash, or you can say it bar, because of the repeating same numbers after the decimal point. It means if you remove this one, it will be going like this: 0.27 27 27 27 infinite. You cannot count the numbers, and because of that one we are putting this bar. It means that thing. Okay, so 0.27 bar is equal to 27. Because of that bar, we replace after the decimal point how many numbers we have? 2. It means each number replaced by in the denominator replaced by 9. Okay, so 27 upon 9. Wherever you see this bar, okay, that after the decimal point how many numbers are there, that numbers, all the numbers will be replaced by each 999. Okay, so 27 by 99 is equal to 3 upon 11. So this will be change into the fraction. Hope you're getting it. Okay, because like you need to go for the practice, get some questions from the internet maybe, or maybe from your book. Okay, and go for the practice. Okay, because you know the math is a subject, like you need to go for the practice. Okay, without practice it is very difficult to do it. Yes, the other example is convert this recurring decimal into a fraction. As we have discussed about the recurring decimals, the number after the decimal point is increasing, or is repeating again and again. Same number, if same number is repeating after the decimal point again and again, that decimal will be called as recurring decimals. Means that number can be recovered, can be change into the fraction. So what we are doing here, 0.33 will be recovered into the fraction. Let's see how we are getting the fraction here. Note that the decimal repeats itself after one decimal place. So let's suppose let's r is equal to 0.3333, the main number we are equaling with the r, and that is a equation number 1. So what we do after that step, multiply both sides of the equation by 10. So first equation we are multiplying by 10 by each side. So when we multiply 10 by r, it is 10r, and when you multiply 10 by 0.333, so it gives you 10r is equal to 3.333. okay, and this is your equation number 2. So by how we are getting the answer, let's focus on that one. What we do in the next step, we subtract the equation 1 from equation 2. So equation number 1 we are subtracting from equation number 2. So equation number 2 is 10r is equal to 3.3333, and equation number 2 is r is equal to 0.333. So when we subtract 10r, sorry, r from 10r, it gives you 9r, and when you subtract 0.333 from 3.333, that gives you 3. So here we need to find actually the value of r, because r will be giving you the actual fraction. Okay, here. So what we do, we divide both sides by 9. Okay, both sides by 9. So it will be r is equal to 9. It will be cancelled from here. It will be r is equal to 3 upon 9. Okay, and it can be simplified more, like 1 upon 3. Okay, so you see, like 0.3333 can be converted into the fraction that is called 1 upon 3 at the end. So hope you got it, because these are something different things, and by watching from the video maybe it will be difficult for you to understand very well. As I said, like, you need to take some notes, you need to go for the copy and note down these examples, and maybe from your book you can pick some examples and try to do by yourself. Okay, because like as math is a subject, you go for this practice more and more. Okay, so this is a last example which we supposed to do for the decimals, and that's it from my side. Stay home, stay safe in this tough situation, and thank you so much.